right, kids, last week we made a spinning coil motor. And when you were working in your groups, you tried to explain what was happening with that coil motor. Why was it spinning? So what I'm going to do is go back in your science journal now, in your notebook. Look where you wrote down on 219 in the lab where it was a spinning motor, and see if you can find your explanation. And what I want you to do right now is to read it silently to yourself. Read it over again because it was last week. How did you explain why that coil was spinning? So reread what you wrote, and then in a few minutes we're going to ask you to share at your table with the people sitting next to you what they wrote so everybody can hear each other's explanation. We're doing this just like real scientists. Real scientists, they'll work in their lab or with a few people, and they'll work together on something for a pretty long time to try to figure something out. And then they'll get together as a larger group to talk about their data, evidence, and findings to try to make sense of what they're learning and what they're exploring. So we're going to do that today. So right now, silently read over what you wrote, and then we're going to share in your table groups. So right now, read your own silently, please. Okay, it looks like most of you are finished. What I want you to do is take turns and having everybody read aloud what they wrote, so that when we get back together as a whole group, we can talk about our understanding together. All right? So you can begin.
I think when the electricity passes through the wire and the elevator starts moving to the coil, it's strong magnetic field, which is the opposite of magnetic.
You want to like go around the room?
What? The question is. I think it's the opposite. There's the coil.
Okay, good. Let's look up here at the learning goals. I was listening to you talk about your explanations, and let's look at our targeted ideas or learning goals for this unit. And does anyone see a learning goal or a targeted idea up here that really might have been mentioned or explained a little bit more in your explanation? Nick?
I'm going to say the relationship between electricity and magnetism.
Okay, so when you were talking about why that motor worked, you had talked about magnetism and electricity in your explanation? All right, any other learning goals or targeted ideas up here that really helped you to explain what you were seeing in that lab? Is there anything else that makes sense there? Yeah.
Build a spinning coil motor.
Right, that's exactly, yeah, that's exactly what we were doing. We built it, and now we're trying to explain how it works. And we were using the words magnetism and electricity in some of our explanations. Is there any other ones that might have helped us in the explanation that we already learned about? They said relationship between electricity and magnetism. We were actually built the motor, and we're trying to explain how it works. That's one of our ideas, targeted ideas or learning goals. What else? Is there anything else?
If you built compass and found magnetic north, then that may have that will have something to do with the magnetism, and it may cause the spin stronger.
Okay. So the idea is just understanding that there is a north and a south pole, and learning about magnetism may help you think about the spinning of that coil. There's one up there that really makes a connection to me too in the design of the motor. Can anybody see what that is? Vinny?
Identify magnetic materials.
Okay, we'd have to know what would work in the design, absolutely. There's another one too, Nick?
I'm going to say that this isn't right, but like parallel and series circuit may help.
Okay, well, it had involved electricity. Is there another one? Stephen? There's one that really sticks out to me that really kind of helps me to think about the design. You see one up there that we worked on? Okay. Vinny?
I was thinking construct an electromagnet because the coil might have some magnetism in it.
Okay, we had a brain match there. I was thinking about the coil around wired with the electricity running through it, and that made that bolt what?
It got magnetized.
And we could pick up paper clips with it. So, you know, the coiling of the wire, which was what we did in the spinning coil motor, made me think. So, a lot of the things that we've learned previously here actually helps us to think about what we learned. So, I'm going to turn on the smart board here, and when it comes up, we're going to see the spinning coil motor. And I think what we ought to do now is, once we shared at our tables, to come up and try to make some sense of this design. Try to figure out why this coil spins when the switch is turned on. So, let's look back to our explanations. And is there somebody, I can pull sticks here, let me get my sticks, that would like to get the first shot at doing this? Let's see. Let me see what my sticks say. Nick, would you like to come up? Let me bring this up for you.
Go.
All right, come on up. What do you know about this design? Just anything that you had in your head about why it might work. Now, right now, this isn't even quivering here. Let's see, do I have the switch on? It's not going to spin, but you can see it quiver. So why is it really quivering?
When the electricity flows through the wires.
Okay, come on up and point to, let me turn the lights out so we can see this. Okay, so point to what you're talking about. You have electricity flowing from what?
From the battery through the wires. It goes up through there and into the coil and into the bare copper wire. It goes onto the coil wire and attaches that, and it kind of makes a magnetic field which hits the magnet and makes it repel.
Oh, okay. So what you're saying is, good, Nick. Thank you. So Nick was saying that as it comes up through here, the electricity travels, and this is copper, so it conducts electricity. Is that right, Nick? And you're saying that when the electricity goes through this, you said it created what?
A magnetic field.
A magnetic field, and then we have a magnet down here. You said something about repelling. Who agrees with that, or has something to add, or wants to change what he said? All right, come on up.
I just really want to add something.
Okay, well, come on up and add it and show us what you're talking about, please.
Well, what I think is it all depends on what you have as a power source, like battery, maybe one or two. And the reason that it actually is quivering is because the switch, if the switch is on or off, that's the whole deal, because all the electricity is counting on the switch to either be turned on or off.
Oh, well, why would that make a difference if the switch is on and off?
Well, because the electricity won't flow if the switch is off.
And what do we call that in a circuit if it's on or off? Do we have, if it's a, do you ever, can anybody help him with the vocabulary? He's right. If the switch isn't, what do we call it?
I think it's a closed circuit if the switch is on, and open circuit if it's off.
Yeah, do you remember that? Yeah, I think I like that. Yeah, so there's a closed circuit you're saying, and that's about the electricity flowing through it. So you're adding on to what Nick said. All right, I need Becky up here. Thank you very much. Come on up and add some more to your understanding, from your understanding to the rest of the group, so that we can think a little more about it. So what do you want to add? We have people saying that now that this is a closed circuit, we have electricity running through here, creating a magnetic field, something about repelling this coil with the magnet. What would you like to add to that, or is there anything? Go ahead, up and point to what you want to say, and show us on the model. So, is there anything different, or do you disagree or agree with what they're saying? You agree? Is there anything you could add to that? What about the fact that if it repels, is there anything else going on if it just repels? Okay, a little louder. There's a magnetic field. Show me where the magnetic fields are. Point to them. Around there and down below. Both, or just, wait, let me see what you're pointing. Do that again. around the magnet. Anywhere else? There's a magnetic field around a magnet, and is there any other place there's any magnetic field? Okay, you think inside the cup, all right. Does anybody want to help her out and see if you know anywhere else? Go ahead, Al.
The wires have a small magnetic field.
Okay, because how do we know that? What's your evidence to that?
Well, an electromagnet has to have electrons running through it to make it have a magnetic field, and the wires have electrons.
Okay, so, and we know that. What proved that to us in one of our labs? How did we know that? Do you remember way back when? What was our evidence that when we put something underneath there, it moved? Do you remember what that was?
When we used different variables to change the electrons.
Oh, okay, so when you remember when you changed the variables electromagnets, absolutely. Becky, do you remember way back, what did we put under the wire that was evidence that there was, the compass, yeah, very good. Remember when we were doing, and we put the compass under the wire, we knew that it moved the compass, there had to be a magnetic field? All right, so his evidence and her evidence were a little different, but it still proved the same thing. That was pretty cool. So we have electricity creating a magnetic field. And so show me where else the magnetic field would be up here then. It's around a magnet, obviously. Was there another magnetic field besides under this wire? Where else would there be another magnetic field happening around
Well,
there?
under these wires.
Uh-huh.
And I think, well, I don't know, actually.
Okay, good. Well, that's all right. Why don't you two sit down, we'll give somebody else a chance. Is there any other place that there might be a magnetic field in here? And what would be the evidence for that? All right, Tyler, come on up.
I think there might be a magnetic field around the copper wire.
Okay, show me what you already mean
Like,
specifically.
like when the wire gets to the alligator clips and like can trigger a magnetic energy that goes right to the copper wire.
Okay, and this wire, what wire?
It's when it gets to this wire, it can triggers magnetic energy to this, and once it turns down, it can triggers energy to the magnet.
Oh, okay, so you're saying there's a field here working with this. Anybody want to add to that? Yeah, good job. Anybody want to add to that? All right, come on, Nick, one more time. Come up and see if you can, you keep adding to your ideas, that's good.
Just a connection that I kind of made.
Okay, well, what's your connection?
Well, I remember back in like the other, I remember back in the, in
One lab?
no, it wasn't magnets and motors,
Oh.
it was something else. It's like, and.
Oh, kinetic and potential energy. Oh, I'm so glad you're bringing that up. So how is that connected to this design?
Well, what I think is, the reason it is connected is because, well, it's using energy to power it, and and the movement is actually energy, so they call that
Kinetic energy, yeah.
And then when it stores up the energy, I'm guessing in the battery, when it switches off, it's potential energy, so it uses potential to power
The kinetic energy then is when this is spinning? All right, how many people thought about that? Raise your hand if you thought about kinetic energy with this. Raise your hand. Okay, I have a couple of people. That's a really good connection, because you learned that in 5th grade, right? About kinetic and potential energy, and we talked about it in our other kit, and now you're applying it here. Nicely done. That's what scientists do. They think back to things that might not even in your head be related, but then find there is a relationship. Nicely done. Yeah. Yeah, question. And that's what scientists have. I like it.
I can't find any sense.
Yeah, did you hear what she said? She wants more information from you. I want everybody to look at your writing and see, do you have, she's saying everybody's explaining all these wire things, but you're not explaining what this wire, which you said had a magnetic field, is doing with this magnet. How are they related? How does it help to make this spin? It's not spinning now, but when we have it set up, it spins. Why would that happen? Vinny, come on up.
Well, when the electricity passes through the wire into the bare copper wire,
Mm-hmm,
this creates a magnetic field, which
okay.
has the same, which is north or south.
Okay, stop there and tell Maddie, did you hear what he said? All right, so he's saying, say it again.
That this magnetic field is either north or south.
All right, so you're saying that we have a north and south pole to that magnetic field around the wire. Okay, so we got that. And then what happens?
Well, I'm thinking that these two poles are the same. So if this, say this is south, then I think this is like generating a south magnetic field.
Okay,
And so if this is north, then this is creating like a northern magnetic field. Because when they get close to each other, they start to repel.
okay, so they only repel or do they do anything?
Well, they don't attract to each other when we kept them close. So
Okay, so, okay, I think we're really building on something. Okay, thank you. Let me see if I can restate, Vinny, you listen and see if I'm saying what you said. He said there's a north and south up here, okay, Maddie? A north and south pole, just like this magnet has a north and south pole. And then we're going to use what Nick said, that this is going to turn around. And so that means that north and that south is going to flip when it turns, right? So now come on up and see if you want to explain that now?
No.
Another question, good.
Like when it like flips, does
Yeah.
it want to come back to the magnet?
Does it want to come back? What would make a pole want to come back to the magnet? Because we know this has a north and south too. So what did we learn about attracting and repelling in magnets? Yeah, north and south attract, right? And what? And south and north repel. So does it make sense if you have a south pole up here and this is north, that it might pull it towards there? And when this side, which is the same type of pole here, it pushes it away? Does that make sense to you? How many people, raise your hand if that makes sense to you? All right, so then we have like two poles fighting against each other, and then opposite poles pulling. So would that make sense that kinetic energy would keep them moving, like he said, and it would spin, and then it would keep repelling and attracting? How many people can get that? Because you're all getting pieces of it, and it's making a picture for me. How many people are seeing that picture right now? Yeah? All right, so here's what I want you to do. Is there anybody, before we move on to writing about this, is there anything else that you want to talk about in this design that wasn't brought up? Yeah.
I thought that maybe the red wire could be half of positive and half negative, and then the magnets could be maybe half and half too. And then they could be each one keeps attracting the other.
Uh-huh. All right, so whether you call it positive or negative or north and south, we have these opposite or like charges, right? Whether it's a magnetic charge or an electric charge. And so what we have is we'll go right back to our targeted idea, right? There's this relationship between magnetism and electricity. And this is an example of how those two work together to make something spin. Anybody have an answer to his question? Like if we use red wire, which is what, a bigger gauge, than smaller wire, would it make a difference? What do you think? What would you predict? Because we could test that out, couldn't we? We could actually test that. What do you think? If we use red wire instead of, which is thicker wire, bigger gauge, what do you think would happen? What do you think? Go ahead, Manny. I think, no? Who thinks they might know? Who would like to predict? Go ahead.
It might actually spin slower.
Okay, it might spin slower. Somebody disagree with that? Yeah, Vinny,
well,
what do
I
you think?
think it might spin faster because there's a stronger magnetic force or field.
Okay, and what would create a stronger magnetic force? How would that happen?
I think that if the wire would be smaller, then it'd be easier for the electrons to pass through it.
Smaller or
Yeah.
bigger?
If it was bigger, I think it'd be harder because there's more space to cover, and the electrons might have to spread out more to cover through the whole thing. And with the smaller wire, they would be able to be closer together and have a stronger charge than spreading out to cover the whole big wire.
Nick, you had your hand up. Did you want to say something?
Just
You're agreeing with somebody, okay. Go ahead, Vinny, you
Well,
haven't bought that yet, huh?
I remember in Brain Pop video, it said that it depends on like the length and width of the wire to the magnetic fork. And I
Uh-huh.
think it said that the bigger the wire, the more charge it would get.
Mhm.
Because the battery, it delivers how much the wire can hold. So if the wire can hold more, then it will deliver more.
Yeah,
Oh, I think I remember the brain pop that he's talking about, only, what I think I remember it definitely saying that they said that the bigger the wire, the less of a charge, and the smaller the wire, the more of a charge.
okay.
Because I also think I remember hearing you say that if you had a bigger wire, there'd be less of a charge, and smaller wire, more of a charge.
Okay, so we could find out the answer by looking at the video again and reading some more. And, oh, no computer. No, we have a problem with the computer. All right, so I think, you know what I love about science is that I hear you thinking about new questions. And you know what happens when scientists get together and talk about things just like we did? The exact same thing happens. They're still trying to ask those questions to understand better what they're studying. And you were just absolutely wonderful at thinking today. And so we're almost done here with this. And what I want you to do is get to a new page in your journal and write down sense making, a spinning coil motor, and then highlight that in your journal, please. Highlight that. If you need a highlighter, we have them in the back. So write sense-making spinning coil motor on a new page and highlight that. And what I want you to do is to think about everything that was said up here today. And I want you to write down in your own words, neatly, what you're understanding now as we got together of how this spinning coil motor works. So right now, in your own words, explaining what you heard up here of how this motor works.